Hi, everyone. This video is going to be an introductory video to these things called imaginary numbers. Okay. Now, imaginary numbers, okay, they're just numbers that cannot be plotted on a real number line. Okay. What I mean by that is, and I'll show you an example. It cannot be plotted on a number line. Okay. So up to this point, if we've got like x squared equals -1, okay, we've taken the square root of both sides and we've said, oh, wait, we can't take the square root of a negative number. So we have said no real solution. Now, the key word there is real because technically there is no real numbers, but there are imaginary answers to that problem. Okay. Now, the big fact for this whole idea about imaginary numbers is that this letter I, which stands for imaginary, is going to be the same exact equivalent or equal to square root of -1. Okay. So we can do math problems where, like, these radicals, these square roots on the bottom, are our final answers, but we can go a couple steps further now rather than just say stop, no real solution. Okay. So the square root of -9 is equal to the square root of 9 times -1. Okay. Now, these two, if I multiply this, the rule is I can multiply the two numbers under the radical and I'd get -9. The reason we do that is the square root of 9 is plus or minus 3. And then we're going to use that math fact that I is equal to the square root of -1. So this turns to be 3I, plus or minus 3I. So the same thing here. 25 and -1. The square root of 25 is plus or minus 5. And then I. Now this one over here, 144, -1, plus or minus 12I. Okay. Now, what happens in this case, assuming my screen will go, is that what happens when the radicals aren't perfect squares. Okay, so for example, 72, the square root of 72 is not a perfect number. Okay, so over here, I'm going to do something that's helpful, not two. I'm going to write a list of all the perfect squares that we know from 1 to 15 squared. So 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Okay. Now we're going to look for the highest number in this list that goes into 72, in which case it is 36. So I'm going to rewrite it first like this. So 72 and -1. Because just like before, we have the square root of 72. And we're going to replace that -1 root with I. So now we're going to look for the biggest number in our list that goes into 72, and it's 36, because 72 can be broken up into 36 times 2. The square root of 36 is 6, root 2, I. Now, sometimes you'll see me put the I in front because I don't want you to get confused and think that the I is underneath the square root, which it's not. Okay, so going through these couple of other examples, square root of 20, square root of -1, this turns into I. And so the biggest number that goes into 20 on our list is 4. So root 4 and root 5. The square root of 4 is 2. So 2I root 5 would be my final answer. Okay, now 48, -1, which turns into I. The biggest number on here is 16. So 16 and 4. Nope, 16 and 3. Sorry, mental math error there. The square root of 16 is 4. I root 3. And that's the introduction to imaginary numbers. Thanks for watching.